In this tutorial, we will create a jump controller and some surrounding components that we need for this. To have an idea what we want to do, I created a quick and dirty jump controller. This component requires a rigid body. We can store a reference to this rigid body in the awake method. The jump is configured via a public direction and force field. And when we are jumping, we apply those to the rigid body's velocity. To prevent jumping in the air, we check against a grounded field, which is set to true when we collide with the ground and set to false when we leave this collision. Be aware that this script is untested and very likely will have a lot of bugs. But nonetheless, this is the basic concept of a jump controller in Unity. But this is insufficient for our modular test-driven approach. For instance, the target rigid body and the check whether we are grounded or not should be externalized. Thus, we will implement the following pattern. Our jump controller will have two GameObject handles. One references a GameObject with a rigid body. The other one references a GameObject with a component that allows iteration over colliders. These represent colliders we are currently colliding with. This jump controller then only needs to check whether any collider is present. In another tutorial, we will create a wall jump controller, in which we will use those colliders to figure out our jump direction. And a trigger controller will implement this interface and store those colliders we are currently colliding with. But we will first begin with a very helpful extension. So we add a new script folder named Tools, and in there we add an extension script. The extension will assert that a GameObject has a certain component. If this component is not present, an exception will be thrown. In our first test, we will assert that a component is present. So we add a rigid body to a GameObject and then retrieve this rigid body via assert component. Then we add this method and let it return null. I also added a constraint for Unity components, but I later realized that we don't need that. The implementation now simply wraps getComponent. Now we assert an exception when the component is not present. GetComponent usually just returns null if the component is not present, which in my experience makes debugging sometimes harder than it needs to be. We implement this behavior via GameObject try_getComponent. If we find a component, we return it, and if not, we throw an exception. We add another test to actually get a useful exception message, which means we now catch the exception and assert the message. And now we add the message to our exception. And I realize I messed up the test, because I was testing against the exception and not the exception message. And now this seems to be okay-ish. I just need to update the expected message. I add an overload for a GameObject handle, which I leave untested because it is just a simple wrapper. And I also later realize I actually want to use this overload for a GameObject wrapper, not a GameObject handle. And as mentioned before, I also removed this component constraint. Now it's time to add the triggers controller. The first test makes sure that by default the triggers controller is empty. The controller needs to implement the IEnumerable interface. This interface consists of two getEnumerator methods. One of them returns a generic IEnumerator, the other one comes from the non-generic IEnumerable interface and returns a non-generic IEnumerator. Canonically, this one simply wraps the more specific getEnumerator. And for now we just yield one null item. And in our implementation we simply break the iteration. In our next test we add one collider via collision. For this component our colliders need to be triggers. We add one game object labeled other. One of the two colliding game objects need to have a rigid body, and we add it to the other game object in this case and set use gravity to false. We also add a sphere collider to other. We instantiate our triggers controller and add a sphere collider as trigger. We wait one frame for the start method, another frame for the update method in which the actual collision detection happens. And then we assert that the triggers controller contains the one collider from other. We now use onTriggerEnter to store the other collider in a private list. Finally, getEnumerator iterates over this list and yields each item. Running both tests created a one-time error, which I tried to reproduce but just couldn't. I'm not really sure what happened here, but it seems to work fine for now. Next, we want to make sure that when we leave the collision, we also remove the collider, which means after the first two frames, we simply move other far, far away. After one frame, our controller should be empty again. We implement this via onTriggerExit. I refactored this to use a dictionary instead of a list. Now we can add our jump controller. First, we add a mock for our trigger controller, in which we simply store colliders in a public list. And this time I utilized getEnumerator from the list, which we could have also done in our triggers controller. In our first test, we want to jump by adding an upwards velocity. We instantiate a jump controller and a target. We store the target via GameObjectWrapper and also add a triggers mock, which we also store via a GameObjectWrapper. We need to make sure to write this as a unity test, because we intend to retrieve the components from our targets in the start method. We also need to make sure that we add a collider to our triggers mock. After adding the missing fields, we run the test. But it fails with an unexpected null exception, because we try to add a collider to a non-instantiated list. And for now we use a dirty minimal approach solution. We can now already refactor this by retrieving the rigid body in the start method. And we use the assert component method for this, so that when the game starts, we are immediately notified if something is amiss. This is also where we realize that our assert component does not target the GameObjectWrapper. Next, we want to prevent jumping when we are not colliding with anything, which means in our mock we won't add any collider. On the implementation side, we retrieve the triggers controller in the start method and check against whether it contains colliders or not. Next, we want to be able to control the force of the jump. We set it to 2 and make an appropriate assertion. We also add the missing field and run the test. After it failed, we simply multiply the vector with the force, which means our first test now fails, but this is simply corrected by setting a default value. Now we want to change the direction of the jump. So we set a new direction and assert the velocity against it. We add the missing field and run the test. And now we need to incorporate this direction in our velocity. And because we have no default value, other tests fail. So we simply set the default to vector up. We also want to make sure that the direction is always using a length of 1. We set a new direction which is definitely not 1, and assert against the normalized vector of this direction. which should be half of square root 2 for the direction y and z. To solve this, we simply use direction.normalized. Let's incorporate it in our demo scene. First, we trigger the jump event when we are pressing space. It should be sufficient to check for this every update. We also add a jump event handle. And raise it with our jump input. Next, we add a game object for our jump behavior. We add a jump controller and set the required fields. We set target rigid body and target triggers to the player handle, which will change in the future, and add an event listener for the jump event. In our last tutorial, we changed the player model to a capsule, and I also updated the collider to a capsule collider. But this one will not be our trigger. First, we will add a rigid body to our player and constrain the rotation axis. And then in play mode, we will see what happens. And our assert component will tell us that we are missing a component. So we add the triggers controller. This at least fixed the error, but we still cannot jump, because there are no trigger colliders on our player. We fix this by adding one for the ground detection. In the future, we will add other colliders for horizontal collisions. But here we need to make sure that this one is a trigger. And hooray, we make very tiny jumps. Setting our force to 5 will let us jump decently. If you are going along with this tutorial, it might happen that you run into some null reference exceptions. This is most likely due to accessing a game object on a handle before it is set. We can fix this by going to Project Settings, Script Execution Order. We add our game object handle set controller and give it a negative priority, which means it will run before all other scripts that have no priority set. Lastly, we want to make sure that the direction is always applied locally. We set a forward direction and then rotate our target upwards and assert against an upward velocity change. To implement this, we simply multiply the target rotation with the direction. And in our demo scene, we can try this out by simply jumping upwards and forwards. But this is it for this tutorial. In the next one, we will implement wall jumping. Let me know what you think, and thanks for watching.